students, I am Subhashish. Trigonometric ratios are like hidden tools in nature's toolbox. They help us measure things that are hard to reach or see. Imagine you are building a tree house and need to know how long the ladder should be. Trigonometry helps you figure that out. It's also like having a superpower to understand angles and sides in triangles, which is useful for making maps, designing buildings, and exploring space. So, whether you are an architect, an astronaut, or just curious about the world, trigonometry is here to help you solve real life puzzles. Learning outcomes. At the end of this lesson, you will be able to understand trigonometric ratios and their relationships in right triangles. Apply complementary angles concept to trigonometric ratios. Express trigonometric ratios using complementary angles and unit circles. Solve problems involving trigonometric ratios and complementary angles. Keywords from this lesson are complementary angles, trigonometric ratios, unit circle, right angle triangle, Pythagorean triplets, reciprocal ratios, angle conversion. Recall that two acute angles are said to be complementary if the sum of their measures is equal to 90 degrees. What can we say about the acute angles of a right angle triangle? In a right angle triangle, the sum of two acute angles is equal to 90 degrees. So, the two acute angles of a right angle triangle are always complementary to each other. In the given image, the triangle is right angled at B. Therefore, if angle C is theta, then angle A is equal to 90 minus theta. From that, we can find sin theta is equal to opposite side by hypotenuse. That is equal to AB by AC. Cosecant theta is equal to hypotenuse by opposite side, that is equal to AC by AB. Cos theta is equal to adjacent side by hypotenuse, that is equal to BC by AC. Secant theta is equal to hypotenuse by adjacent side, that is equal to AC by BC. Tan theta is equal to opposite side by adjacent side, that is equal to AB by BC. Cot theta is equal to adjacent side by opposite side, that is equal to BC by AC. Consider it as 1. Similarly, for the angle 90 minus theta, we have sin 90 minus theta is equal to opposite side by hypotenuse, that is equal to BC by AC. Cosecant 90 minus theta is equal to hypotenuse by opposite side, that is equal to AC by BC. Cos 90 minus theta is equal to adjacent side by hypotenuse, that is equal to AB by AC. Secant 90 minus theta is equal to hypotenuse by adjacent side, that is equal to AC by AB. Tan 90 minus theta is equal to opposite side by adjacent side, that is equal to BC by A. Cot 90 minus theta is equal to adjacent side by opposite side, that is equal to AB by BC. Consider it as 2. Comparing 1 and 2, we get sin theta is equal to cos 90 minus theta, cosecant theta is equal to secant 90 minus theta, cos theta is equal to sin 90 minus theta, secant theta is equal to cosecant 90 minus theta, tan theta is equal to cot 90 minus theta, cot theta is equal to tan 90 minus theta. Let us see one example. Express sin 74 degrees in terms of cosine. Solution. Sin 74 degrees can be written as sin into 90 degrees minus 16 degrees, since 90 degrees minus 16 degrees is equal to 74 degrees. Right hand side is of the form sin 90 minus theta is equal to cos theta. Therefore, sin 74 degrees is equal to cos 16 degrees. Express tan 12 degrees in terms of cotangent. Solution. Tan 12 degrees can be written as tan 90 degrees minus 78 degrees, since 12 degrees is equal to 90 degrees minus 78 degrees. Right hand side is of the form tan 90 minus theta is equal to cot theta. Therefore, tan 12 degrees is equal to cot 78 degrees. Let us see another example. Evaluate sin 49 degrees by cos 41 degrees. Solution. Given sin 49 degrees by cos 41 degrees. Sin 49 degrees can be written as sin 90 degrees minus 41 degrees, since 49 plus 41 degrees is equal to 90 degrees, complementary. RHS is of the form sin 90 degrees minus theta is equal to cos theta. Therefore, sin 49 degrees is equal to cos 41 degrees. Hence, on substituting sin 49 degrees is equal to cos 41 degrees, we get cos 41 degrees by cos 41 degrees is equal to 1. Let's see some more examples. Find the values of tan 7 degrees into tan 23 degrees into tan 60 degrees into tan 67 degrees into tan 83 degrees. Solution: tan 7 degrees into tan 83 degrees into tan 23 degrees into tan 67 degrees into tan 60 degrees. Grouping complementary angles. That is equal to tan 7 degrees into tan 90 degrees minus 7 degrees tan 23 degrees into tan 90 degrees minus 23 degrees into tan 60 degrees. That is equal to tan 7 degrees into cot 7 degrees into tan 23 degrees into cot 23 degrees into tan 60 degrees. We know cot theta is equal to 1 by tan theta. We get 1 into 1 into tan 60 degrees. From trigonometric table, we can get tan 60 degrees is equal to root 3. Example: if cosecant A is equal to secant 34 degrees, then find A. Solution: we know that cosecant A is equal to secant 90 degrees minus A. That is, secant 90 degrees minus A is equal to secant 34 degrees. That is equal to 90 degrees minus A is equal to 34 degrees. We get A is equal to 90 degrees minus 34 degrees. A is equal to 56 degrees. Example: if tan B is equal to cot 47 degrees, then find B. Solution: we know that tan B is equal to cot 90 degrees minus B. So, cot 90 degrees minus B is equal to cot 47 degrees. Ninety minus B is equal to 47 degrees. We get B is equal to 90 degrees minus 47 degrees. B is equal to 43 degrees. Points to remember: in a right angle triangle, the sum of the two acute angles is equal to 90 degrees. The two acute angles of a right angle triangle are always complementary to each other. Sin theta is equal to cos 90 minus theta, cosecant theta is equal to secant 90 minus theta. cos theta is equal to sin 90 minus theta, secant theta is equal to cosecant 90 minus theta. Tan theta is equal to cot 90 minus theta, cot theta is equal to tan 90 minus theta. Thanks for watching.